So how far did y'all get? Did you get through these exponent ones?
Yeah.
Yeah. Did you get this one with the negative on there?
Yes.
How's a negative change things?
You flipped the problem.
Is that what you did first?
Yes.
Because there's different orders we could do these in, right? If you did it in different order, as long as you're getting the same thing. This is what, 7z to the 5th then, and this is y on top. And we're doing this to the positive 2 now. So we flip it and we make the exponent positive. And then what do we do?
I multiplied everything by 2. Did I do that right?
What do you mean multiplied everything? So
Like
on top we have y to the what?
Second.
Y to the second.
And then for the bottom, I did 7 times. Not by 2, but by to itself, right? Because I did 7 times 7.
Yeah, if you tell me 14, you're gonna break my heart a little bit.
Yeah, because I had to
Add the 7 squared, right? Don't do 2 times 7.
Yeah.
Make sure you're putting that up in the exponent. That's an exponent, stays up in the exponent. And z to the 10th. And one thing I can clean up is I know what
7 to the second is 49.
Yeah, I know what 7 squared is 49. So what about this problem do we need to take away? Probably like negative exponents flip things, right? If we have a negative exponent, that means that they need to get flipped. You could distribute it first, but that's not the way we did. But that's one way you could go, right? And like this 2 gets multiplied to each exponent, not to the base, right? Exponents get multiplied to exponents. When we raise exponents to exponents, I think one of the more common things is people try to multiply like 2 times 7 is 7 to the second. Questions about this one?
So I'm just trying to double check because I want to make sure I'm saying it right. What I'm supposed to do is multiply the exponent, like to it to the other exponents, right?
Yeah, so it's like that's just 7 to the first there, right? And so
Yeah.
we're multiplying that 1 times the 2 to make it 7 squared.
Okay.
Okay, and so the final thing is y squared over 49z to the 10th. And I think if we look in the back of the book, their solution is just like that thing flipped. That's all that negative is doing, is flipping things. All right, and then we got a few more on 1. We have what, 3x 0 versus 3x to the 0. And then we've got f and
So
q.
it's just 3.
Which one? This one? Is that what you're saying?
Yeah, the first one.
The first one's 3. Yeah, the first one's 3. What is the exponent on the 3 in the first one? So that, I think that's probably the thing that throws people off.
There isn't one.
Yeah, so we don't see 1. We can put a 1 up there. That means it's to the first power. So this is like a 3 to the first power times an x to the 0 power. I think what people sometimes try to do is they don't see that, and they try to tack that 0 on there. They try to make it that second problem. That's basically what they do, right? And here they're trying to get you to look at this thing and hopefully realize like these are 2 different things. On that first one, the 3 has a 1 exponent. On the second one, that whole thing is to the 0 power. So that whole thing is what number? Oh, this is the easy one.
1.
Yeah, this is one you rejoice if you see that thing on the test, right? It's like, if I tack a negative, ooh, I don't have that. But if I put a negative there, how would that change it?
It would be to the negative 1.
If I did put a negative on the outside, it would tag along to the.
No, it is 1.
If I put a negative on the inside, does that change?
No, it's
No.
1.
If it's 1. Okay. So that's that one. The next one is testing sort of the same thing I think I was just talking about, right? If we have a -5 and we square it versus a what -5 squared, they're both 25. I'll give you that much. But
On the
how are they
left-
different?
On the left, a negative times a negative is a positive.
Uh-huh.
And on the right, how do I get that? It's going to be a negative times a positive is a negative.
Yeah, so it's sort of like there's a -1 happening there, and then we're doing the 5 squared separately, right? And so we're doing the 5 squared is getting me a 25, and that negative is kind of tagging along on the outside. So we're looking at this kind of separately, like there's a negative hanging out on the outside. So if I don't put parentheses around the negative, it's not included like within the exponent.
Yeah.
It's kind of separate from it. And I think that's kind of working up to like when we go plug things back in, right? There's a negative on my x squared. That negative's kind of on the outside. Unless I'm putting it in parentheses.
It's going to be
And so what we're doing? We're doing 2 now. Questions about these? Anything to the 0 is 1. If the negative is on the inside, the parentheses, it's getting squared or it's getting the treatment of the exponent. If it's on the outside, it's just tagging along. So what do we have? Y to the -6 over y to the -2. So what am I doing here?
Are you asking question?
Yeah, we have y to the -6 over y to the -2. If I'm dividing things, what is that? How does that operation transfer to the exponents?
Is that
This
just
is-
3?
For the exponents, you have to add them.
If we're dividing,
You subtract them?
we subtract them. If we're multiplying, we add them.
Yeah, so you're gonna go 6 minus 2.
Yeah, it should be a -6 minus a -2. So this is one of those things.
Right.
You have to watch your negatives, I think is what this the name of the game on this thing is, right?
So you're gonna end up with a -4. Why to the -4th?
And they don't want us to write things as negative exponents. So one extra little thing.
Keep it down.
1 over y to the 4th.
Yeah, y'all got it. Probably get rid of that double negative, right? If that helps you. So I know you may not have to write all these steps out, but like I would suggest writing it out. You know that the definition of subtraction, seeing that double negative there. If not, there's a good chance you might mess up on a negative or something like that, right? Okay. Next one is this is almost too silly. What is the one thing? I think there's just one negative exponent on here, right? So what does this look
Yeah,
like?
right?
What's on top?
What's the answer to the last one? Sorry, I was like writing down what you were writing down and I just got confused.
It was 1 over y to the 4th. We got a y to the -4. Just had to flip it. Come on, go forward. Nope. That's as far as it wants to go forward, apparently. Okay. X squared. I guess it's got a limited memory on it, on its history, I guess. The undo and redo button. What do I have to do on this thing?
Excuse me, teacher, which number? It's 2A or
2C, I think is what we're doing now, right? That's what I told y'all to do. 2B and C.
Okay.
So I have 8y to the -1 z squared over x squared.
Yeah, okay. Can I do this? if you want?
So what
I want to just flip y down and put it as 8z squared over x squared y.
x squared y, or you could do maybe yx squared. Probably
Yeah,
say x
whatever.
squared y since it's alphabetical order. But if you did it the other way, that's fine.
Okay.
Basically, it's going on the bottom, right? That negative
Right.
thing's going on the bottom. If you did a first power on here, I'd still give it to you. That's good. The thing that's negative gets flipped. If it's on top, it goes on bottom, bottom goes on top, right?
Yep.
We're basically flipping them to the other side of the division bar. All right, so
Excuse me. You want us to put it as alphabetical order? Or it's okay.
so either way, to be honest, I would count it correct.
Okay.
But by convention, we typically go like an I can't even speak, alphabetical order.
You mean in this case, I want to write like the 8yz squared over yx squared, right?
8z squared over x squared y is what you told me. That's right. That's
Mm.
alphabetical.
Okay.
And number 4.
Number
Have you got through number 4? Did y'all look at number 4?
Get that
Yeah.
far.
Took number 4 off. You said we was gonna do 5 and 6.
Let's do 4, 5, and 6. I'm gonna give y'all like 5 minutes or something to do those 3. Is that good?
Here it's just multiplication.
So on, one moment.
I'll set up 6 for y'all. I'll do 4 and 5, and then I'll set up 6.
So number 4, I got 6. Oh, I'm sorry. That was interpreter error here. I wanted to just give my answer for number 4. Can I give you that answer?
Sure. I don't know if it's correct or not. I have to look.
Okay, so I just want to see if my answer, I'll explain kind of what I did. I multiplied. Oh, well, so I looked at the 4.6 times 3.0,
Mhm.
got that, and then times 10 to the, I have negative 20 as one exponent, and then plus 8.
Do -11.
And so now I'm looking
So
at
10 to the, let me think.
What is the negative of that?
So it'd be 8 minus 20, so it'd be negative 12.
that is good. There is one little thing. That is how we like do the multiplication. That's how we do this operation. We just have to clean this thing up a little bit. That is an almost scientific notation, but it's not quite there. There's like one extra little thing we got to do.
Right, right. So you want it to be a positive exponent, right?
No, the negative exponent in scientific notation is perfectly fine. What's happening is this thing right here is 13.8, and I only want one digit in front of there. So I'm going to step back and I'm going to explain like what happened right quick. This thing is all multiplication. So what Charmaine did was she saw like everything's multiplying. I can put the 4.6 and the 3.0 and I can multiply those two things together, right? This is how we multiply things in scientific notation. Do it quickly. So we're multiplying those two base numbers, the 4.6 and the 3.0, and then the powers of 8 we look at separately. So she did the 8 minus the 20 and the powers of the 10 and got 10 to the minus 12. And this is almost scientific notation. I'm gonna have to fix things a little bit.
To
And I'll
move the
probably write things
finger-
upside down.
You change the decimal place, you change the power, correct?
Yeah,
So
because
just
I'm going 1.38.
1.38 to the negative 11th.
So I'm gonna think about this. It takes me a second to think, but this is getting smaller.
Right. So it's going to be 10 to the negative 11th.
Yeah, so minus 11 is larger than 12, minus 12. So yeah, this has to get larger. And it stays the same number. If one of them gets smaller by a power of 10, the other one gets larger by a power of 10, that is going to be the same number. So you might have to shift that decimal a few places. If you multiply things that are fractions, you might have to shift it the other way, right? If it's smaller numbers. Okay. With that in mind,
Sounds good.
what about this thing? I hope you look at this thing pretty similar.
Number 5.
Yeah, yeah, number 5 times 10 to the minus 15.
Right.
This is times what? 10 to the minus 9.
Yeah, yes.
So
Times 9.
looking, same sort of approach we took last time, right?
Yes.
2 over 4 is going to give me what?
0.5. No,
0.5. That's half.
and in this case, it's going to be changed.
And I'm
right?
going to go 10 to the minus
40.
something minus something.
Sorry.
Is that
Hey,
minus 15 plus 9? Is that what I'm doing?
minus 15 plus 8 plus 9, 27, right?
It's 15 and 9, so it should be 6.
That's it.
And it should be negative 6. We're doing minus 15 plus 9.
In this case, it's 0.5 times 10 power minus 6, right?
Yeah, so that's there. We're almost there. There's one little shift I have to do, right? So I don't want 0.5, I want what?
5.
5.0, right?
Yes, 5.0 times t minus
Try to squeeze it down here. Times 10 to the what?
5 minus 5.
This one got larger, so this one has to get
Minus 7, yes.
minus 7. It's got to get smaller by 1.
Why do you like this method to write it as 5.0?
5.0 times 10 to the minus 7, right, is like 0.0000 with 6 zeros and then a 7 or 5, sorry. So yeah, so that's why they do that. So we don't have to write a bunch of zeros basically.
How if I want to just 0.5 times 10 power minus 6? Or I need to write it the other way.
It should be 5 times 10 to the minus 7. That's the scientific notation, is to always have that one leading digit.
Okay.
So there should always be just that one leading digit in front of the decimal, basically.
Because the 0.52 is decimal.
The 0 is not, we don't include the 0 as being a digit. It's nothing. There's nothing there, basically. We want like a 1 through 9 in front of that decimal.
Okay. Thank you.
And then the one you asked about, we want to do what? 9.58
No, please. We can do.
times 10 to the 7th miles.
Okay.
That's what they give me. I'll try to like do that all a little smaller. I'm not running out of room. 9.258 times 10 to the positive 7 miles. And there's a sort of thing we can do. They're just giving this as like miles. If you want, you can write it over 1, but it's basically on top is what I want to realize. And then they tell me there are 5,280 feet in a mile. And then they're going to ask us how many feet this thing is, I think is what they're asking.
Yes.
expressed in
Well,
distance.
okay, I want to just say if I did the answer correct. You mean we need to do the 5280 over 9.25. No. Yeah, 258 times 10 power 7. We need to divide this equation, or okay.
So there is a thing like they do called unit analysis that might help you out here. If I have miles on top and I want to cancel out miles in my second fraction, I need to put miles where? On top or bottom?
In the bottom.
On the bottom, right? And so miles to feet, I think, is the conversion I want to do.
Yes, we need to find the feet.
And so they tell me 5280 feet in a mile. I'm going to write that out in scientific notation, I guess 5.28 times 10 to the what, third?
Third, yes.
If I convert that to scientific notation right quick, for every 1 mile is the conversion factor. So what we're going to end up doing is multiplying these two numbers. And my unit analysis kind of tells me that because they both end up on top and they both have those ones on the bottom.
Okay.
So we did one that was multiplication. I want to jump to the next step so that we have enough time to do it. Where did I put that? Now where did I put that paper?
Teacher, excuse me. In this case, we need to just to do the multiplication between the two numbers, right?
Yeah, so those two things should be multiplied.
But for me, when they said we need to find it as the feeds, I need to go out of the miles to divide miles, the miles in the top with the miles in the bottom, and to find just with the feeds.
So you multiply it by how many feet are in a mile. Multiply miles by feet per mile, it will get rid of the miles and it will put you into feet.
Yes, I need to multiply with the feeds. No, with miles.
All right, so 2B's, 2C, we did 5 and 6. We walked through those. 11, I think, is the next one I want to do. Oh man, so I don't feel like this is the most difficult one, but like a lot of people missed it. I felt like y'all got some of the more difficult concepts in this section.
Yeah,
Or y'all tended to be stronger in some of the more difficult stuff, and then like stuff like this, I was like, but that is like putting two functions together. That's the cost in dollars for computer chip production. I guess I could share my screen that I'm looking at and stop sharing that one. That would probably be better. But I want to do 11, which is this cost in dollars. I want to do 13, A, D, and E. And I want to go to 14. I want to do A, B, E. So I will put that in the chat, but those are the next few I really want to look at. 11, I want to do 13, A, D, E, and 14, A, B, E. And then we will look at 15 as the last one. I guess we'll look at that as well. If you don't get to it, you can do it while I'm doing it, I guess. 15, I'll throw 15 in there. Where are we at? Yeah. All right, I'll give y'all some time to work on these. Bring y'all back in about 10 minutes. See where we're at. If y'all need more time to work on them, I'll give you a little bit more time. But factoring is a pretty big part of this test. So we do need to spend some time on factoring and those sorts of things. 11. Yeah, that's just compositions of functions. Or not compositions, but I should be able to do that. We'll go over it. Breakout rooms. Not recording this yet. Okay. And then the second part, this is kind of like what we did, I think the last test, right? When we did function notation, what does it mean to put 100 into this thing right here? That means I'm plugging 100 into my X value everywhere in my function. Okay. That is 11. What else did I tell y'all to do? 13 ADE. Did y'all get through those?
Real quick on the last one, I'm sorry, I know I keep doing this, I'm just trying to like write it all down. The formula was negative 0.3x squared plus 47x minus 14, right?
So we were, let me get it like all well adjusted. So P of X equals minus 0.3x squared plus 47x minus 14 when we put it together.
Okay, I just had to make sure. Thank you so much.
Sure.
I mean, we need to do the 13th here, right, teacher?
So we're doing 13. What was I doing? A, D, and E, I think are pretty good practice. Did y'all get through those? Are y'all still working on those?
Still working on those.
A, D, and E. So we got a few more minutes. We got a little bit more time. I can give y'all a little bit more time to work on this stuff. I want to do A, D, and E on 13. So this one is just factoring, right?
Yeah.
Okay.
You see,
And then on 14, I want to do A, B, and E. Oh man, does that almost lines up? No. I want to do A, B, and E.
Yeah, I haven't finished those yet.
Okay, I'll give y'all more time on them. Okay. Let's go to groups. They're a lot easier to find if I stop sharing. Here we go. So we started with 4 terms. We factored by grouping. After we factored by grouping, there was still a little bit more work we could do. We see a difference of squares. We should end up getting this thing when we expand it.
Which is a prime, right? Because of the positive, or did it?
Okay, so we're
does it
looking
have
at
to
each
be a
thing
positive
here.
before the equation starts.
So if you look at this thing here, the 2x plus 1, the x plus 3, and the x minus 3.
Mhm.
And you might want to know if these things are fully factored. The thing that tells me that these things are fully factored is like all my x's there are to
Yeah,
the
it's
first
very
power,
factor,
right?
yeah.
I can't simplify that out any further. We're trying to break it down to its single x components, basically. And so when I get to x to the first, that's basically all the way broken down. I can
You
go
mean
when
the
I go
final
when
results, teacher, excuse me.
when I go and do equations with this, right? I can solve it really easily if it's like a
So
x to the
it was
first.
only. It would only be a prime if it was a binomial.
Usually we only say something is prime if there's nothing we can do with the original equation, right? If there's work that we're doing,
We can
like
factor.
technically
Okay.
each of these is prime, right? Because we can't break it down any further, but you're not ever going to tell me that word unless that is the only thing that you can do, right? Unless there's nothing you can do. Then you're telling me
We can-
prime to tell me that, hey, there's nothing else I can do here. So if we look at something like what, D?
Excuse me,
D-
teacher. I mean,
D is a
if we need
prime.
to say this equation, it's prime. When we can't move anything in the original. Like we can't find the grouping. We can't factor in it, right?
Yeah, so if the original
Okay.
one, if there's nothing you can do to it, then you tell me prime. But usually you're not going to use that word unless there's nothing you can do.
Okay, thank you. Because sometimes you confused me. And then, okay.
Questions about this A? Are we getting A, hopefully? Our factoring techniques can be like layered in each other. So you always got to check your solution, make sure it's fully factored. What are we doing? D? Is that what we're doing next?
Yes.
Says what, 9x squared plus 16.
This is prime.
This is it prime?
Yes,
Yeah,
This is a square and this is a square. Why are you telling me it's prime?
because of the sign.
Because it's a sum, right? If it's not a subtraction, if it's a sum of squares, we're calling them prime, right?
Yes.
yeah.
So D, you put prime, you should be done, right?
Yeah.
A, D, and what did I say? E, is that what the other one was?
A, B, C, D, E. I think yes. E.
2x to the third minus 12x squared
Yeah.
plus 16x.
Yes. Here you have your GCF, which is 2x.
Yeah, so I think the name of the game on this one is if we look at it, you could try like maybe doing the AC method or something else to get factor this thing, but really the first thing you should look for is what?
GCF.
GCF. If you factor out that GCF, it'll make your life a lot easier in this thing, I think. And so if I'm looking between 2, 12, and 16, what is my GCF there?
2.
I can factor out a 2.
Mm-hmm.
If I'm looking at x cubed, x squared, x to the, this not here, but this is an x to the first power.
It's your x.
I can take out a single x from all these things.
Mm-hmm.
And so this is like the guy hanging on to the outside of your truck there. When you're not looking, he just climbs up. But there he is. He's just gonna hang on for the ride.
The remaining is your x
What's this?
squared x plus 8.
X squared minus 6
X plus 8.
plus 8. So we're dividing everything by a 2x.
Yes.
So everything just get divided by 2. That gives me a 1, a minus 6, positive 8. We're taking an x down from what it's there. So if it's an x cubed, it's going to x squared. X squared is going to x single power. We have an x, there's no more x's there.
Yeah.
Dividing that out, that's our GCF. Now what are we focusing on?
It's a method to grouping.
This thing on the inside, right? And so we're looking at 3 terms. What is a way I can break down 3 terms? AC method. Yeah, that's what you're saying. AC method, it's got to multiply to what? 8, add to minus 6.
Which is 8 and minus 6, minus 4, minus 2.
Yeah, minus 4, minus 2.
Minus 4 and a minus 2 will give me a negative 6 when I add them and a positive 8 when I multiply them. So I have a 2x here. Did y'all do AC method?
Yes.
Okay, yeah, you can do AC method. That's fine. There is a shortcut for these two as well, but it only works when this thing is 1. I do it with the AC method. It's getting messy here. Okay. So I have a 2x. I have this thing I broke apart with the AC method minus 4x. And if I break it apart with the AC method, what's the next thing I do? I have 4 terms now.
Yes, one is minus 4, another one is minus 2.
Yeah, factor by grouping.
Your GCF is still there, 2x times x minus 4 and x minus 2.
X times x minus 4 here. We pull out an x. And then what do we pull out from this?
Minus 2.
A minus 2. It's leading with the negative. We pull out the negative. And if I pull out a minus 2, does that leave me with an x minus 4?
Is your plus 8.
You can distribute that if you want to check. But that should leave me with minus 2x plus 8. That's it. And so what are my factors? Now, this is where we got to be careful, I think. Because I think y'all will tell me x minus 4, right? And what?
And x minus 2.
And x minus 2. And if you tell me that, you did a wonderful job of factoring that thing.
You still got to bring down your 2x.
Yeah, there's
You
still this
see
creeper hanging on
everything.
the outside of your truck here, right? 2x, bring him down.
Yeah.
Is that like Point Break or something with Robert De Niro where he like clings onto the axle of the truck? Something like that. That's who that 2x is there. That's realistically happening. Okay, so that's 13. What did y'all get through 14? Did you get started on 14?
I started on 14, but I didn't get a chance to finish it.
You can do it directly.
All right, so let's do this one right quick, and then I'll give y'all a few more minutes, I think, maybe to do them on your own. I think this one's a pretty quick one, hopefully. How do I do this? So I look here, it's got a 1x squared, so there's no GCFs.
Yeah.
If we're
It's
gonna
in-
solve it, the first thing is to set it equal to 0, right? But it's already there. We look for our GCFs. There's no GCFs there. The next thing I see, hopefully, is that it's got 3 terms. So
AC
how do we do
method.
3 terms? AC method.
Yes.
It's got to multiply to minus 28 and add to what? Minus 3.
Yes, minus 28 minus 3.
What is that? 7 and 4.
Yes, minus 7 minus 4.
7 be a negative. That should
Yeah.
be.
It's 7 minus 4, sorry.
It should be a minus 7, so the 3 can be negative, right? When we add them,
Okay, yeah, sorry.
when we multiply them, it should be minus 28.
Yes.
Do you want to do work or do you want to do a shortcut? Can I do the shortcut here?
Yes.
Yeah, this is a 1x squared. So maybe I'm throwing a little shortcut at you, but I think I did it already in the notes.
X plus 7, x minus 4.
All right, this is a positive 4, right?
Yeah, positive, yes.
So this should be x plus 4x minus 7 when I factor it.
Mm-hmm.
And I have this thing x plus 4, x
Yeah.
minus 7, and what do I know about these two things? They're equal to
0. You find the-
0. And so now I'm looking at this thing.
when your x plus 4 equals to 0, x minus equals to minus 4, and the other one.
There's an x plus 4 equal to 0. So we're using the 0 product rule. Either this first thing here is equal to 0, or this other thing that's here is equal to 0, or both of them could be 0.
Yeah.
This is it. X is equal to
No.
7.
minus 4, is that what you said?
Yes.
I heard something kind of cut in and out. That's it. We subtract the 4 to make it over.
And that would be positive 7.
Yeah, we add the 7 to make it to the other side. Yep. Okay, where are we at on time? All right, so I want to give y'all just a few minutes, 3 minutes. I want you to look at 14B, 14E. They look really similar, and I think that's why I chose both of these. So if you haven't done them already, go ahead and do them. We will have one that looks like 2x squared equals 6x is one of them, and then the other one is 9x squared equals 16.
One of them is the prime, another one is
Mm,
the 9x squared minus 60 plus 16.
So what is the
Okay.
first thing you have to do to these if we want to solve them?
For the 2x squared equals 6x, you have to move 6x to the other side, right?
We got to set one side equal to
0.
0. So we want to move that 6x to the other side.
which number, teacher? Is it D or is it B?
On 14B, we're gonna subtract 6x. It should be the first thing you do. You want to make one side equal to 0.
I am in the 13B, sorry.
And with E, right? What about
Mm.
E? What's the first thing we want to do there?
For your E,
Same thing, like set it to 0.
Mm-hmm.
And
Yeah.
you subtract,
This should be your first approach. So I want to give like people just like a minute or two. Look at these things. I guess I'll write them out. I can't write them out. I don't know how to write anymore. Okay. Equals 0.
X minus 10.
I feel like part E is like kind of by the formula, but maybe I'm wrong. I feel like that one, the formula is probably jumping out to you. This one, maybe not so much. If we have something like we have 2x squared equals 6x, we talked about it. Like the first step, if I'm going to factor something, I'm going to use the 0 product rule, right? So the first step is like, I got to set one side equal to 0. If this thing, right, and I talked about it in the notes, if that's anything other than 0, I can't use those assumptions like when I multiply by 0, things equal 0, right? It
Mhm.
doesn't work. The 0 product rule only works with the 0. So the first strategy is to set one side equal to 0 if it's not there. After we set one side equal to 0, we have something like 2x squared minus 6x equals 0. I'm thinking about factoring. So if I'm thinking about factoring, what am I doing? What's the first thing?
Do we are in the 14E?
I'm looking at 14b right now, 2x squared minus 6x.
Okay.
If I want to factor that, how do I factor that?
You wanna have your GCF as 2x,
Yeah, so the GCF is 2x.
and it's then in the remaining is x minus 3 and 2x
I have an x minus 3.
equals to 0. X equals to 0, x equals to 3.
Okay, so you skipped a few steps there, but let's break it down.
Yeah.
So the first thing I see there is what?
You have your GCF.
I have a 2x, right? So one possibility is that 2x is 0. The other possibility is that
X minus 3 is a 0.
that other term there, the x minus 3 is a 0. So if 2x is 0,
Your x is 0.
I divide both sides by 2. 0 over 2, is that okay?
No.
0 over 2 is 0.
0 over 2 is 0. If I have nothing and I divide nothing evenly by 2 people, those 2 people are going to have nothing.
Of
That is
course.
fine.
Mm.
We can divide nothing by people. Everyone's going to have nothing.
Mm.
It's the other way around, right? Dividing by 0 and makes the universe. Don't do it. X minus 3. If I move that 3 to the other side, this is going to tell me x is equal to
3.
3. Okay. And that was what? B?
Mhm.
Is everyone getting this? I go on. Are we moving on to E?
Mhm.
Yes, please.
Okay. Moving on to E, how does that differ? If I have a 9x squared minus 16, and this is equal to 0, I think is where I was at. I moved that 16 to the other side.
Yeah.
Does that have a
Well,
It would be
GCF?
9.
I'm sorry, what was that?
So would it be 9 then? Divide each side by 9?
So you wouldn't be able to divide 16 by 9 evenly.
Yeah, we can't.
So I don't think there's a GCF here. What sort of format is it?
Oh, my bad. My bad.
It's 3 square, square, 4 square,
This is a square, this is a square, and what do we see in the middle?
A negative.
minus.
A minus. So what sort of thing is that?
It's like 3. It's going to be 3x minus 4, 3x.
Yeah,
plus
yeah, yeah. Okay, so the thing is called the difference of squares is the formula. That's it. And so I look at this first thing. If I want to take a square root of 9x squared, what is that going to give me?
3x.
And if I want to take a square root of 16, what is that going to give me?
4.
4. So I know I have a 3x and a 4, a 3x and a 4. And what about the signs there?
One need to be positive and the other one need to be negative.
Yep, that's the difference of squares. And we know this thing is equal to
0.
0. After I know this thing's equal to 0, we've done a few, so I think I'm going to speed it up through the end of this thing. I know that either that thing's equal to 0 or that thing's equal to 0, the 0 product rule.
Mhm.
If I solve that first one over there, 3x plus 4, I have to subtract the 4 to the other side. So 3x is what? Minus 4. I think this is giving me a minus 4/3, and I think the other one will probably give me a positive because I'm going to have to add that 4 over.
Mhm.
And I've done these for like 12 years, and so you just like start seeing these patterns. Okay, one of those is negative, one of those is positive. It's all you need is a time machine and take 12 years to study this stuff.
Mhm.
Your family sees you 1 second later and you're 12 years older. That's perfectly all right. They don't suspect a thing. Okay.
Quick question. Will we ever have, okay, for 14C, will we have a problem like that? Will we still have to set that to 0?
Oh yeah, I used to have to set that thing equal to 0.
How you do that? I was looking at that one, but I was like,
So this is probably, it looks like it's almost factored, right? Like that side does. But no, yeah, so I think what we have to do is distribution. Right, 3x squared plus 6x. And we have to move terms to the other side. So I want to hit that last problem right quick. So I'm not going to do this, but I'll set you up to get there, I guess, a little bit. So you would have to do maybe some of the most work on those, right? On like C and D, because not only that, you have to distribute it first, and then you have to move things over to make it 0. So yeah, I'm glad you asked.
Okay.
If I want to get to 15,
Yes.
got a few minutes.
I think, okay, maybe on the 16. I have a question on the 15, teacher. When you're asking for the points in the graph, do we need to draw the graph or just to give you the points?
Just the points, just the x comma y in the parentheses, right?
This one, we don't need to have to draw the graph or whatever, right?
Yeah, so let's read this. P of x is 10x squared minus 17x. And they want to say solve P of x is equal to a minus 3. So what does that look like? What is the equation I should write based off of like these two things?
Your equation is going to be equals to minus 3, which is 10x squared minus 17x equals to -3. We move -3 to the side and everything is going to be equals to 0.
So we set this thing P of X, which we know is 10X squared minus 17X. And this is
Plus
telling me
3.
set that thing equal to -3, right? Set my P of X equal to -3. This equation should be -3. And now we want to solve for
X.
the correlating X values that match this Y value over here. So we're looking, and you said it already, but we want to set one side equal to 0. So we do something like 10X squared minus 17X.
Plus 3.
And when we move the negative to the other side, we're going to add it. So this is going to be plus 3. And this is equal to
0.
0.
Okay.
Okay, so now I want to do what? 3 terms. I think I'm factoring this AC method.
Yeah, AC method, it works too.
I believe 30 and a minus 17 is what we want to do.
Yes. 3 minus 17. I think here.
3 and 10, I think
Yes,
are the magic
I have
numbers.
15 minus 2.
3 and 10 don't work. 15 and a minus 2.
Yes, 15 minus 2 is, no, minus 15 minus 3, sorry, minus 15 minus 2 is going to be plus 30, minus 15 minus 2 minus 17. Yes, this
Yeah,
one.
that's it. Minus 15 minus 2. So I like I almost did, right? And I think
Mhm.
some people do this when they factor. You have to make sure like your signs also match up. Sometimes things will
Yes.
match up except for the sign, right? I think 10 and 3 would probably add to like minus 17 somehow.
No,
No,
we can't.
I did that wrong. No. But 15 and 2, right?
Yeah.
They will add to minus 17. They will multiply to a positive 30. So we want to break this thing apart doing the AC method.
By grouping them.
Minus 2x plus 3. We're going to factor this by grouping. And I am right there at 240. I'm going to finish this up and we'll be out of here. So this is what, 5x. And I have a 2x plus 3 in here.
Plus 3, 5.
And I have a minus 1 and a 2x. Sorry, this should be 2x minus 3.
Yes, I think it's
And
minus
a minus 1 and a 2x minus 3. So hopefully we get our signs correct.
3. Okay, give it 1 second. Minus 3.
And I have a 2x minus 3 as my factors. And I have a 5x minus 1 as my factors.
Yes.
So I know I'm going maybe a little fast over this, but this is stuff that we did already. And so this one is giving me an x equals,
To 1 over 5.
should be 3/2 and 1 over 5, right?
Yeah, because I
Positive
just-
3/2, positive 1 over 5. If we set these equal to 0 and solve them. So we get our solution for the x. We've done that already on previous problems. And so what are my points? My x
Okay,
is 3/2.
minus 3 and the other one minus 3 because we have already our y, right?
And my y is a minus 3. Yep. And so we take our x solution and we pair it back with the thing that we had previously.
Because because I think they don't know if we need to write to draw the graph, but I think we don't need it. Okay.
Okay. And then the last thing, just I'm going to set it up. Now they want to know about our intercepts. So how do I set this equation up to find my intercepts?
Y equals to 0.
My y is now 0, and so I set this equal to 0. I do the same thing. I factor it and solve my intercepts.
When y equals to 0, we have already those points, right, teacher?
One of them is x equals 0. There's like a common coefficient of x, right? That we can take out.
Slow down, please. He said, what is the x-intercept? The x-intercept is when y equals to 0. Yes, okay. No, it's okay.
So we set this equal to 0 and solve it. That's it.
X equals to 0 and another x equals to 17 over 10.
Yep, that's
Yes.
it.
Thank you.
Sounds right.
Do we can do 16 quickly or?
We really don't. I don't have time to do it right now in class. Want to come back after class? I can do it.
Okay, I will come back to you. Thank you. See you there.
Good luck studying, everyone.
Thank you. And I'm just double checking. You guys will be back at 1:45, right?
Yeah.
All right.